All right, hey guys, Mr. Fortin back here again. I got a third way to do this, right? Third way to do this. Now, this is a tough question, number 26, because people come in, it's like, how do I do that? There are so many ways you can do this problem. You got to find your way. So follow your heart, try to get creative, try to move some things around, work through it, take risks, right? And get it done as well as you can. And if not, right, you can watch some of these videos and figure out how I'm doing it here, follow my reasoning, which is an important skill to have. Okay, this last one that I'm going to do, the last way of looking at it here is I want to draw your attention to what we did on Friday, question number 5 from the group work here. This is the hardest one, right? I talked to multiple groups about this. I stayed on block 5 and talked to like maybe about 10 people stay down and talk through this one. But anyways, in this diagram here, we're kind of given, right, on Friday, we were given the same thing that we're given on this problem here, which is a part to part ratio, right? KR is a part right here. RT is the lower left part here, is the same as upper right part to lower right part, right? KS over SU. The problem again with what our givens are down here is that we get a part here and a part here. So we could set up that KR over RT, no problem, but we have a whole here, right? This is the whole, right? We would call this the whole right side, right? Part of the left side, part of the left side. We don't know what the whole, well, we do know what the whole, we'll get to that in a second. This is the whole right. And we just have parts here, okay? But we want to solve for the parts down here. So this is a little bit tricky here, right? A little bit tricky. So we have this proportion here, okay? So we have a few ways we could potentially do this. I might show you one way right now. This is 12 and that's 4. Well, what's KT? KT is 16. So check it out here. We actually do know in this problem, right? We do know what the ratio is, right? We know what the ratio is between the left side lengths and the right side lengths, right? We do, right? We do. This is 16. This is in a 16 to 20 ratio. So if you've watched other videos, you know this. These are all in 4 to 5 ratios, right? 4 to 5. So this has got to be 5 and that's got to be 15, right? We can solve this really quickly here because this is in a 4 to 5 ratio, 16 to 20. So it turns out even if you're given parts to like we're given that parts to parts is true, then it turns out that the whole to part ratio is going to be true as well. Because if over here, if this is 16 over 4, that is in a 4 to 1 ratio, then this is going to be 20 over 5. Again, 4 to 1 ratio. What's 20 divided by 5 is 4. 5 divided by 5 is 1, right? So 4 over 1, right? 4 to 1 ratio. So it turns out here that if we know this, we also know that the wholes, okay? So we have here KT over RT is going to be the same as KU over SU, okay? We can jump to this conclusion. So that's why I wanted you to hopefully justify that on Friday, that if I have a part to part, right? This is part to part, right? Proportions, right? Proportions between these parts of a segment and these parts of a segment, then we can actually say that the whole to part ratios are also equal to each other. So we have another true proportion right here, okay? So just quick reminder on how we did that, right? How we did that in this problem right here, for instance. So I could even just change the writer here, okay? So we're given this, okay? We did this some ways here, and I'll just reiterate this in case you're like, what is the deal with this problem? How did I do this one? Maybe you're watching, maybe you're not. I'm just gonna do it real quick so you can switch back to the, or fast forward to getting the sheet of actually doing this problem if you'd like to. But the reason why this works mathematically, and you've seen it kind of observing it in these last two problems, but mathematically, the reason why it works is here, well, if I want to get hold apart down here, well, in this problem here, we actually had to invert both fractions first. If I know that this is true, I can invert both fractions, and then I get this. Okay, I get that, and they explain this all down here, but I get this by inverting both these fractions. This was important for this problem because now I have KR in the denominator, I have KS in the denominator, and that's what I want to change to. So this is part to part, but we need to move the different parts down in the bottom here, right? What we ultimately resulted to. But that doesn't matter for this, the problem you're doing for homework here. The problem is, how do you get the whole, right? If I have part to part ratios are true, why is whole to part true? And it turns out I can add denominators here. So if I wanted to get KT here, I can take this KR, right? And do the denominator add property proportion. So here I did invert the fraction first. That's what you did do on Friday. Then I have to do denominator add, and I get RT plus KR is over KR, right? I just added that denominator here, one of the properties of proportions that we have here. And then I'm adding KS here. So I get SU plus KS, and that's over KS. And here, look, KU. What's another way we can write about KU? What's KU? Well, KU just equals KS plus SU. Look, this plus that, KS plus SU. So I have KS plus SU right here. That's equal to KU, so I can substitute that, right? I can use substitution property to ultimately get to what I wanted to show, which is that the whole to part ratio here has to be the same as, and here, RT plus KR, we got RT plus KR, that equals KT, right? I can put KT over here, equals the whole to part ratio. And that would be true for the other part here too. These ratios, they just all connect, right? These proportions we can do, right? Part to part ratios, that if we have a proportion that works, then the other part to part ratio would work. So we flip both fractions, or if we get them be whole to parts or part to whole, right? If I invert both of these, a part to whole ratio results in the not part to whole proportion would be valid as well too, okay? So in this particular problem right here, we can think of this. This is 16, that's 4, this is 20. Well, let's make that 1x, right? We can go part, or we can just say that's SU. We can know 16 over 4. So here, let me get rid of this here. This is whole to part, actually. I did the work here. KT is 16, RT is the part. So 16 to 4 ratio, this would be also in a 5 to 4, or not 5, sorry, 4 to 1 ratio as well. So, but you can just solve for it, right? You can solve for it here. This is 16 to 4. This would be in the same ratio, 20 to whatever this is. SU would be in a 4 to 1 ratio. So you can kind of do it in your head if you want, realize this has to be 5. Or what can you do? You can just solve for it, right? This is only one unknown here within a ratio. You should know how to solve stuff like this because you can do cross multiplication, okay? So this is going to be 16 times SU. So there's 16 SU. I say in comments, I say cross multiply and divide, right? Cross multiplication I just did, and then 4 times 20 is 80. And then when you cross multiply, oftentimes you have a coefficient here in front of the unknown. So cross multiply and then divide, right? You'll hear your teachers say that, cross multiply and divide. And did I make a mistake here? Did I make a mistake? This looks wonky. No, it's not, right? Because 16 times 5 would be 80, right? 50, it would be 5 times 10, and then 6 times 5 is 30. So yeah, 50 plus 30 is 80. And there we go. Man, math. Good stuff. So maybe really watch this. If you're not sure where I'm coming up with this, come to office hours, try to seek out help. But this has got to be 5. Again, 5 plus 15 is what's going to bring us to 20. So I didn't even need to think about that at all. If this is x, that's 20 minus x, right? 20 minus 5 is 15. And therefore we can get this good to go. And this KT is the easy one. Segmentation-Postulate brings us to 16. Okay, thank you for watching this one. I think by watching all of them, right, maybe you'll find a method that works for you. And if not, keep practicing and keep pushing yourself, keep questioning, keep taking risks. I will see you guys later. Bye.